Welcome to our NLP class. This is part 19. In this class, we are going to learn about PCA model, Principal Component Analysis model. So, we have studied that the PCA model is meant for dimensionality reduction. Here, the objective is to capture the maximum information in the input vector space. Here is our input vector space. When it is mapped against another space, where all the vectors are diagonal to each other. Here the main objective is to capture maximum information from this input space. Here let us just consider x and y, two dimensional space, and assume there is an unit vector u. This is u, and if there is that point x1, let us assume there is a point x1 on this plane x and y. So, what would happen if the x1 is projected on this unit vector u? And we know that when it is projected on u, this unit vector, this norm of this vector, this distance is called as the information captured by this vector u from this x. Now, let us try to understand how much information this unit vector can capture. It is based on where the location of x1 is. So, let us assume that x1 is here on the same axis on the unit vector. Then the amount of information would be the length of this vector u1. On the other side, if this if it is projected, if it is this needs to be projected on this unit vector, it is projected on here and we get the information of vector length u1. On the other hand, let us assume that this x1 is here, which is orthogonal to u. When it is projected here, the length is 0. So, now we know that the length, that means amount of information captured, would be maximum when this x1 is on this plane, that unit vector space. So, this is defined as the inner product of x and u. So, this x prime, after projecting on this unit vector space, the information can be calculated by using this formula. X prime is equal to the inner product of x and u, which is multiplied by u. So, the amount of information preserved can be calculated using this xtu square. This is amount of information or details preserved by this transformation, linear transformation. Now, here in our PCA model, the PCA model needs to be defined such a way that the amount of information preserved is maximum. So, here what is the objective function in our PCA model? Is maximizing this information for all I. So, just we saw only one example. So, when we look at all the points, it is I equal to 1 to n and xi transpose u square, where u is an unit vector. So, u transpose u should be equal to 1. So, this is the objective function and this is my constraint. So, do you know how to convert this optimization problem with constraint into unconstrained optimization problem? There is a way which is called as Lagrangian method. Now, what we can do is, by applying the Lagrangian multiplier, we can convert this as an unconstrained optimization problem. What should we do is, we just have only the objective function xi t u whole square minus, this is my Lagrangian multiplier, and u2u minus 1, because this constraint can be rewritten as ut minus 1 equal to 0. So, now my optimization function becomes like this. So, this equation can be rearranged for our convenience like this. I, where this can be written as u transpose xi t and u minus lambda t lambda minus lambda. Now, how do we maximize this function? We know that if we take the gradient of this function and equate that gradient equal to 0, then we can find out the maximum values of this equation. So, let us take the gradient of this function, then it would become, so let me just rearrange little bit further, that u t, before taking the gradient, I am just rearranging the equation xi x t and u minus lambda u t u minus lambda. Here, do you understand this terminology? The multiplication of xi and xi transpose. This is a covariance. The covariance can be with the simple notation, we can written this as a sigma u minus lambda u t u minus lambda equal to, now I am going to differentiate, and after differentiating this would becomes 2 lambda u minus 2 lambda u equal to 0. Now, this becomes lambda u equal to lambda u. Do you remember this equation? In our last class, we studied about this equation. So, whoever is new to this class, please go to that previous class and learn about this equation, the relationship between the covariance and these vectors and the value lambda. Here this sigma is covariance matrix, and u is the eigenvector, and this lambda is the eigenvalue. Here it can be rewritten as this covariance matrix, this is my eigenvector which is equal to eigenvalue which is multiplied by my eigenvector. Now, we have simplified our equation. Here what is this eigenvector means and eigenvalues means? The eigenvector defines the direction of the mapping, and eigenvalue measures the amount of details captured. Now, we will see with an example how we can compute this eigenvalue and eigenvector, and how we can use this eigenvector. The eigenvector is used for the linear transformation of this function. Eigenvector is used for the linear transformation of this function f of x from my input space x y into the output space x prime and y prime. This is the PCA model. So, in order to develop this PCA model, the three terminology we need to compute. One is covariance matrix, another one is this eigenvectors and eigenvalues. and we all know that how to compute this value. Let us just see a simple example and then see how we can compute these three factors. So now our objective is to find out the authors of list of documents. Let us assume that there are maybe 100 documents, and each document is written by an author A1 and A2. Maybe some of the documents are written by A1 and some of them are written by A2. Then A1, the author A1 writes only about fairy tale story, and A2 author writes about maybe science fiction. Now we have all the documents, but we do not know which story is written by which author. That objective is to find out the author name for each document. For each document, we know that list of words appeared in the document, and we know how to convert this word into the numerical vector. We need to apply pre-processing step, and we need to apply some feature extraction step or word embedding step. And after applying all these pre-processing and word embedding, we will end up with having our input space. Let us assume that we have come up with 5 features, that is x1, x2 up to x5. Now we know this x1, my input space, x1, x2, x3, x4 and x5. What is this size? There are 100 documents, so there are 100 observation in my input space, and this is all my numerical values. Let us assume this is something 4.2, 1.5, something, all numerical values. So now I have specified my input vector. Now we need to, in order to compute this PCA model, that define the PCA model, we need to compute this eigenvector and eigenvalue. In order to do that, we need to compute our covariance matrix. What is this covariance matrix? Already we know this definition of covariance matrix. For this 5 dimension, it would be defined as x1, x2, x3, x4, x5, and here my x1, x2, the vector, that matrix dimension would be 5 cross 5, the eigenvector dimension. First one would be, it's a variance of x1 and covariance of x1 and x2, again covariance of x1 and x3, this is covariance of x1 and x4, this is covariance of x1 and x5. So we can define our covariance matrix. This is variance of x2. Similarly, we can write our covariance matrix. This would be x3, and this would be my x4, and this is my. So when we look at the covariance matrix, the diagonals would be all variance, and then off diagonal would be covariance. Covariance matrix is a symmetrical matrix. So by calculating this one, we can easily calculate eigenvalue and eigenvectors. So that already you know the formula for variance. Variance is just calculating this xi, the minus x mean the whole square divided by n. This is the formula for variance. We know the xi, and we know we can compute this x mean, x1 mean, x2 mean, x3 mean up to x5 mean. We can compute means of all these features x1 to x5, and we can compute variance of all these features. Then we need to compute covariance for any two combination. How do we compute that covariance between x1 and x2? So, already we have seen the intuition behind the formula. Whoever is new to this class, please review my previous lectures on this topic, principal component analysis, to understand more about these concepts. And covariance between x1 and x2 is written as, this is for all i's, I just compute x1 of I from the mean value and then multiply this one with x2 of I, x2 mean of I. So, this is the formula for covariance. Now, I know my variance and covariance. Next step is computing u and lambda. So, we know the formula. U is my eigenvector and lambda is the eigenvalue. Since the input space has 5 features, which is x1, x2 up to x5, we can compute eigenvectors of 5 dimension. Eigenvector u1, eigenvector u2, eigenvector u3, u4 and u5. So, this would be my eigenvector and I will have my lambdas. Now, we already knew that this PCA is meant for dimensionality reduction. We just want to use the first few components which captures most of the information given in the input vector space. So, after computing this all the information, eigenvectors and eigenvalues, just rearrange these eigenvectors and eigenvalue by looking at the eigenvalue score. Just to take the highest one, for an example, if lambda 3 is the highest one captured, maybe lambda 3 captured 90% of the information or 85% of the information, then this vector u3 is my primary, that first principal component PC1. So, because the lambda 3 is the highest one and which capture 85% of the entire lambdas. This is my principal component 1 PC1. Let us assume that next one is this U1. U1 is my second principal component and with value lambda 1. So, the lambda 3 and lambda 1 defines the magnitude of information captured, and this V3 and V1 specify the direction of the mapping from the input space to output space. For the same example, we can see for the house. Let us assume this is my V3 and this is U3 and this is U1. This can be captured. V3 is captured by keeping the angle of the camera here at this direction, and I will map it on another plane. For V, this is the mapping using V3, and again another one is mapping using U1, U1 and U3. So, after mapping into 2D, now we have reduced the 5-dimensional space into 2-dimensional space. Maybe U3 would be capturing in our example, all the information that are related to a fairy tale story, maybe U1 would capture all the information details related to science fiction story. So, when I map the input vector x1 up to x5 into the new space, maybe let us assume that this is the original space. Just for my understanding, I am just plotting 5 dimensions. It is not possible. Just for my understanding, I am plotting 5 dimensions. Here all my documents, there are 100 documents. I cannot differentiate which one is written by which author by looking at this input space. Now I applied the PCA. PCA extracted 2 principal components, PCA1, principal PC1 and PC2, principal component 1 and 2. This is my eigenvector U1, this is the eigenvector U2. When I map it on this new plane, which are orthogonal to each other, now I would be able to see 2 clusters of the documents. Maybe these documents are related to the author 1, these documents are related to author 2. So, using this principal components, I can differentiate the 2 documents and I can identify the authors of those 2 documents. Now, we know the application of the principal component analysis. One is it used to reduce, now I will summarize what we can do with principal component analysis. The principal component analysis reduces the dimension. This is computed by calculating covariance matrix and the eigenvector and eigenvalue. We have learned that how to compute covariance matrix, eigenvalue, eigenvector. Please review my previous lectures to understand more about the calculation of these terminologies. And after calculating this, we can identify the principal components PC1 and PC2. These are eigenvectors. These eigenvectors captures around most of the information from the input space. Using these eigenvectors, you can reduce the dimensions and either classify the documents or it can be used for the classification problem, unsupervised classification or unsupervised segmentation models. Or this can be used for the sentiment analysis. Just the one first principal component would be describing about positive sentiment of movie reviews, and PC2 could be explaining negative sentiments of the movie reviews. In so many ways we can use the principal component analysis. Thank you. Bye.